Okay. Here we go. Oops, that's the wrong piece. Okay. So, yep. I'll just jump right in here. All right, so before we get into adding and subtracting, let's just answer some. Let's kind of talk about some, like, well, I don't know. We'll just jump into some examples here. Okay, so I'll call this rewriting. Before we get into the actual adding and subtracting, we're just going to get into rewriting rational expressions first. Okay, so again, we're talking about expressions today, adding and subtracting them, right? So expressions, right, they don't have an equal sign, right? So we're not going to be solving for x in any of these cases. We're just going to be taking two things and adding them together, right? And that'll be kind of our answer. We won't be, they'll have x or other variables in them, but we're not going to be solving for x because we're not going to have like an equation. We won't say it's equal to something. We're just going to be, coming up with an equivalent form, I guess, or whatever. Okay? So something that we want to be able to do just for our purposes for adding and subtracting, we want to be able to rewrite stuff. So for example, let's say we want to write 3x over x plus 3 as an equivalent rational expression that has a denominator of x plus 3 times x plus 5. Okay. Long directions for the task that we're really going to be doing here, but anyway. So again, in this specific case, the rewriting, we're told explicitly what to do to rewrite it here. We want to take our original rational function, right, or rational expression right there, the 3x over x plus 3. We're going to rewrite it, right, using a denominator of x plus 3 and x plus 5. Okay? So, our current rational expression, right, it already has an x plus 3 in it, right? So what's the only thing that's missing from our denominator here? Again, if our goal is to have a denominator of x plus 3 times x plus 5, what is this denominator missing? An x plus 5, right? It doesn't have one. So we're gonna multiply one in. Okay? So I'll multiply the bottom by x plus 5. Okay? But of course, I can't just multiply the bottom by x plus 5 because that's going to change the value, right? So what also needs to be multiplied on top? What do I need on top here so that I don't change the value of this expression? If I multiply just by x plus 5 in the denominator, I'm going to change the value of this thing. So what needs to go on top? What? A 1. So if I put a 1 up here, okay, well now I'm going to be multiplying the bottom by x plus 5, but the top is just multiplied by 1. So if I put a 1 in here, okay, that's going to change the value of my expression, my original expression here, right? I'm trying to write an equivalent rational expression. So when I take this and I multiply by 1 over x plus 5, yes, I'll get an x plus 5 in the denominator, but I'm going to change the value of this thing. Because does this equal 1? It does not, right? If I multiply by 1 over x plus 5, I'm not multiplying by 1, I'm multiplying by 1 over x plus 5. But what? Yeah, we want to make it x plus 5 over x plus 5 there. Okay? Yeah, there's going to be now a hole in this expression. Exactly right. So we'll have 3x parentheses x plus 5 over x plus 3 times x plus 5. Okay? And now we've satisfied what the conditions were, right? We came up with an equivalent expression to 3x over x plus 3, but that has a denominator of x plus 3 times x plus 5. Okay? So this and this are equal to each other. Okay? This right here, 3x over x plus 3, is the same thing as 3x over x plus 3 times, or 3x times x plus 5 all over x plus 3 times x plus 5, right? This and this are the same. Okay? With one exception, which is what Julian mentioned there, that the this would have a hole at -5, and this one would be okay at -5. So they're pretty much the same, except for this one has a hole at -5. This one does not. Okay, but for our purposes, we'll say they're the same. Okay, all right. That one's a bit weird because I don't know. It's just kind of like a weird set of directions. Let's do something more maybe straightforward. We're more comfortable with, right? Simplify. Okay, so let's just simplify. X squared plus 5x plus 6. Okay. Over x squared plus 3x plus 2 times x plus 3. Okay, so let's say now we just want to simplify. So again, that was one example. Here's another example. Okay, let's say you just want to simplify. So at first glance here, does anything straight up just cancel with what we've got right now? Can we cancel anything out right now with what we with what's written there? Anything cancel? X squares? Yeah, that's a good question. Can we do that? Yeah, no, we can't do that. Nope. Can't cancel those out. Okay. And if you don't believe me on that, let me see here if I can show you an easy way to see that. Yeah. So why can't we cancel the x squared? Does anyone want to take a guess or try to see what about those x squareds won't allow us to cancel them out? Okay, so actually multiplication is not a problem. It's the addition here. We have x squared plus 3x plus 2. And this is x squared plus 5x plus 6. So in other words, the x squared and the x squared, since we have addition in there as well, they don't quite cancel out. As an easy example of that, let me just show you, for example, just to show you a counter example here. If we had 5, 6, right? Let's say we had the fraction 5, 6, right? I could rewrite that as 3 plus 2 over 3 plus 3, right? Okay, right? 5 is the same thing as 3 plus 2, 6 is the same thing as 3 plus 3. This is equivalent to this. But then if I cancel out the 3's, like we maybe want to do here, right, like we have with the x squareds, right? We have x squared plus some other stuff, x squared plus some other stuff. Here we have 3 plus some other stuff and 3 plus some other stuff, right? Cancel the 3's out. Okay, well, we get 1 and a 1, I guess. So you get 1 plus 2, which is 3, and 1 plus 3, which is 4. But is 5, 6 the same thing as 3/4? Are these equivalent? No. And so in general, right, we can't cancel out things when there's addition. So back to my original question, as this is currently written, can we simplify this at all? Nothing cancels, right? There's nothing that's the same in the numerator and denominator, okay? But to simplify here, what can we maybe do with our numerator? Or what can we maybe do with this part here in our denominator? What can we do? They're quadratics, right? What can we maybe do with quadratics? Factor. So for this first one, right, we need to, with two numbers that multiply to 6, but add to make 5. 3 and 2. Okay, all over. And then for this one right here, we're looking for two numbers that multiply to make 2, but add to make 3. 2 and 1. And we still have the x plus 3 there, don't forget that. Okay. Now, do we see anything to cancel out? X plus 3's, right, aha. Right, we have this whole quantity here, x plus 3, and we'll cancel out with this whole quantity here, x plus 3. And the x plus 2's cancel. Okay, anything else cancel? So the entire numerator canceled out. What's left in the numerator still? 0. Well, not 0. 1. Okay? Because what we're doing here, Gio, when we cancel out, we're actually dividing. When you divide something by itself, a 1 is left over, right? So we have a 1 in the numerator still. And then what's left over in our denominator? X plus 1. Okay? So we went from here 2 here. Okay? So that's a more straightforward simplification there, right? Where we factor and things cancel, right? We could cancel the x plus 2 with this x plus 2 because now it was a product, right? It was x plus 3 times x plus 2. And here it was x plus 2 times x plus 1 times x plus 3. So the x plus 2 is also canceled that way. Okay? Questions on any of that? Okay. Let's do maybe 1 or 2 more of these, and then we'll get into the actual adding and subtracting. Well, yeah, sure, we'll do one more here. Let's simplify one more here. So we'll simplify x plus x to the third times 1 minus x squared all over x to the second minus x to the sixth. Okay. So, with what we have right here, does anything right now cancel out? No, unfortunately not. Okay. Can we factor anything in the numerator, for example? Okay, the denominator, what can we take out of the denominator? Cut it in half? What can we factor out? Look for factoring. What's in common to both terms here? We can take out an x squared, right? And if I take an x squared out of x squared, what's left? Just 1. And then the x to the 6th to take out an x squared. If I have x to the 6th, I take out x squared, I have now x to the what? Nope. When you divide it out, we're going to subtract our exponents, so it becomes x to the 4th. Right? Think about it this way, right? X to the 6th, that's how many x's multiplied together? X to the 6th is how many x's multiplied together? 6 of them. We take out x squared, so take out 2 of those, I now have 4 left over, right? X to the 4th. We subtract the exponents there, because we're dividing it. All right. How about from the numerator? What about from here? What can we take out from here? An x, right? An x. Okay. So we have x, and then we'll be left with 1 plus, and then take an x out of x to the third. We now have x to the second. Okay. And then 1 minus x squared, that factors. Okay, it's a difference of squares. It factors to 1 minus x and 1 plus x there too. Okay. All right. 1 plus x squared does not factor, though. That's a sum of squares. There's no way to factor those. All right. 1 minus x to the 4th also factors. I'll factor that here as well. Okay, it's also a difference of squares. So it's going to be factor 1 minus x squared, 1 plus x squared. And then the 1 minus x squared is, well, it is a difference of squares as well. So we'll factor 1. Okay. So I just did a ton of factoring there. Okay. I just did a ton of factoring. So again, from here, we took out an x. Okay. Here, it's a difference of squares, and the factor to be 1 minus x, 1 plus x. Okay. Here, there's a GCF. We take out x squared. Leaving behind 1 minus x to the 4th. Okay. 1 minus x to the 4th is a difference of squares. It factors to 1 minus x squared, 1 plus x squared. And then the 1 minus x squared further factors, because it's another difference of squares, to 1 minus x, 1 plus x. And that's what we get to right there. And now finally, things cancel, right? So what can we cancel from the numerator and denominator here? What's that? 1 minus x and the 1 minus x. What else? 1 plus x and 1 plus x. What else? 1 plus x squared and 1 plus x squared. What else? X and x squared, right? Well, so if we cancel out the x and the x squared, what's going to be left in the numerator now? A 1 over x, yeah. So this whole mess simplifies down to just 1 over x. Okay? So again, that was just some practice of simplifying and stuff like that. But now we're getting to actual adding fractions and things. Okay. Okay. So let's get into some actually adding and subtracting here. Let's get into some actual adding and subtracting. Okay. So here we go. Let's say we've got negative 2 over x plus 7. We want to add to it 6x over 4x plus 28. Do we have common denominators here? No, right? Very obviously not. Okay? So we need to get common denominators, right? We have to figure out some way, okay, to get these two denominators to match up. 4. Okay? So yeah, so 4. Now in this case, right, so let me just kind of show it here, right? If I'll leave the x plus 7 alone for right now, but in the denominator over here, I see that we can take out a 4. Now if I take a 4 out of this, well, if I take a 4 out of 4x, what will be left behind? Just an x, right? If I take a 4 out of 28, what will be left behind? 7. Okay? So, when you come across two fractions, right, two rational expressions that you're trying to add together, if you don't have a common denominator, right, factor the denominators as much as you can. Because before, right, it didn't look like these things were anywhere near close to each other, but now when we factor that second denominator there, we see, oh wait, but they both have an x plus 7, okay? So they're very close to one another. The denominators are similar, right? We have x plus 7, x plus 7. What is this denominator missing, though, that this denominator has? A 4, right? It's missing a 4. So what we'll do is we'll bring a 4 in, right? So we'll multiply by 4 over 4 in there, in that first rational function expression. Okay, right? If I multiply this expression here by 4 over 4, I'm not changing its value, right? It's still multiplying by 1, okay? But I'm using 4 over 4 to get a 4 in the denominator, and then an equivalent, well, I'll get the 4 in the numerator then, okay? So this becomes now negative 8 over 4 times x plus 7. And I'm going to add 6x plus, over 4x plus 7, like that. Okay? Now can we add these two fractions together? Yes, same denominator, right? You can multiply the 4 back through if you want to. I'm going to leave it factored, though, okay? Leave it factored. So negative 8 plus 6x becomes, well, negative 8 plus 6x all over 4 parentheses x plus 7. Right? We've added two fractions together. It's not very nice looking, right? It doesn't really simplify down at all very nicely. Or sorry, it doesn't, combine together or anything like that very nicely, right? No like terms there really, but we are together now at least. It's added together. Okay? We could simplify here, right? I see a 4 in the denominator. And what can I take out of the numerator here that's in common? What's a GCF in the numerator we have? A 2. We can take a 2 out. And then the 2 and the 4 will simplify, right? What's 2 divided by 4? Well, how do the 2 and the 4 cancel? Sorry, the 2 divides by 2 to make a 1. The 4 divides by 2 to make 2. And so I could really make this negative 4 plus 3x all over 2, parentheses, x plus 7. Okay? So we add the fractions together, and then we simplify the fractions. And there's our most simple form. Okay? There's no more GCF for us to take out of the numerator there, so we can't cancel out that 2. If you wanted to redistribute the 2 back through, you can, but it's not necessary. Okay? Questions on any of that? All right. Let's do another one here. No questions so far? We're good? Still see some people writing. I'll hold off then. I can do this. All right, let's add now. All right, so we'll subtract. Okay, we'll do some subtraction here for this one. Okay, so we're going to take negative 14 over x squared minus 11x plus 24, and we'll subtract 9 over x squared minus 6x plus 9. Okay. Yes, good guess. Right, because can we go ahead and subtract these things the way that they're currently written? No, why not? Our denominators are not the same, right? That does not match with this. So we cannot just subtract negative 14, take away 9, right? We can't do it. But let's try and see if we already have some common factors in our denominators. So yeah, we're going to factor our denominators here. So yes, you'll still need to remember how to factor quadratics here, folks. In this case, right, we need two numbers that multiply to make positive 24, but add to make negative 11. Yeah, negative 8 and negative 3. Okay? And then we'll subtract. And now we need two numbers that multiply to make positive 9, but that add to make negative 6. Negative 3 and negative 3. Okay? Now, these two denominators that look way different from one another actually are more similar than we thought, right? They both have an x minus 3 factor. Okay? They both have an x minus 3 factor. But this denominator has two x minus 3s in it, right? This denominator has one x minus 3 and an x minus 8. Okay? So, what is this denominator missing over here that this denominator has? It already has one x minus 3, but it needs another x minus 3. So we're going to multiply this first denominator and numerator. We'll multiply by x minus 3 and x minus 3. Okay? And then what is this denominator missing that this denominator has? An x minus 8. So we'll multiply the top and bottom by x minus 8. Okay? So factoring is super helpful here because it kind of, it makes the common denominator a little bit easier to find. Okay. So when I have negative 14 times x minus 3, that means it's going to distribute to the x and to the minus 3 there. So we'll have negative 14x, and then negative 14 times negative 3, 28, 42. Don't multiply out your denominator. Leave it the way it is. So leave it factored like that. Okay, so the x minus 8, the x minus 3, and then the other x minus 3 right there. But I do want you to distribute the numerator there for sure. Okay, and then 9 will distribute, so 9x, and then 9 times minus 8 is minus 72. Like that. Do we have common denominators now? Yes, right? X minus 8 times x minus 3 times x minus 3 is the same as x minus 3 times x minus 3 times x minus 8. Okay, so now we're going to subtract. Okay, this subtraction, okay, it's really subtracting the entire quantity up here. So I'm going to change it to add the opposites. Okay, and it makes it a little bit easier then. So negative 14 and negative 9, that makes negative 23x. And then 42 plus 72 is going to be 114. Yeah, 114. All over x minus 8, x minus 3, x minus 3. Just like that. Now in this case, there's no way to factor that numerator anymore, so this is as simple as we get. You don't need to multiply your denominator back out. Okay, you can leave it unmultiplied there. Okay? All right, questions on any of that? Want to try one for yourself here? All right, here's 2 for you to try then. Okay, so there's 1 for you to try. And here's another one for you to try. Okay, so give those 2 a try right there. I got 1 adding 1, 1 subtracting 1. Okay? So again, get common denominators. You might need to factor your denominators first, right? But then get a common denominator and go. See what you come up with there. Of course, I'll come around and help. here, try these out. Okay, factor out that second denominator right here. Factor an x out. Number two, you want to factor this second denominator here as well. Okay. See what you need to multiply by to get it to match up. Question? Yes. Yeah, one more minute here. One more minute. Try these out. One more minute. Okay, so let's take a look here at number one. Okay, number one, can we add them the way they're currently written? No, we don't have a common denominator, right? That's x. The other one's x squared plus x. Okay, so they are not the same. All right. All right. It's too bad we can't just like add an x squared into the top and the bottom, right? We can't just do plus x squared and plus x squared here, right? To make it match up, you can't do that. It doesn't just work mathematically. You can't just add in things, okay? But what we're going to do is factor this here. So let's rewrite this as 3 over x plus, what can I take out of the denominator here? An x. I'll be left with an x times an x plus 1. Okay. Now, they both have what in common in their denominator? They both have a what? They both have an x. Okay, so that's good, right? We have something in common. But we're missing here what? Need an x plus 1, right? Yep. So to bring it in, we're going to multiply that fraction there by an x plus 1 times an x plus 1. Okay. Multiply. Okay. So we're multiplying by 1 really though, right? X plus 1 over x plus 1, that's really 1. So we're multiplying this thing by 1. We're not changing its value. We're just going to change what it looks like. Okay. The 3 will distribute, so we're going to get 3x plus 3 over, and then an x times x plus 1. I'm going to leave it unfactored in the denominator. And then bring down, of course, the 5. Now can we add these two fractions together? Yes, right? Common denominator, okay? What gets added here in our numerators? What are our like terms in the numerators? Yeah, the 3 and the 5, right? And so we'll end up with 3x plus 8 all over x times x plus 1. Okay. Can we factor anything in the numerator? Now we've added all our like terms. Does anything in the numerator factor? No, it does not, right? There's no GCF. This is not quadratic. So there's no other way to factor it here. We're done. We don't need to simplify any further. You do want to check, though. There are some situations where it could. Questions on number 1? Okay. So again, factor that second denominator right. See that you're missing x plus 1 in the first denominator, and then distribute and then add like terms. Okay. Notice our denominators do not change when we add, right? The denominator stays the same. All right. Let's take a look at number 2. Okay. Number 2, are these like terms? No. So we have to rewrite, okay? This doesn't really factor, okay? I mean, you can like break it up into parts, right? But we're going to leave it as 7 over 9x squared. Okay, but this denominator does factor. What can we take out of this denominator here? A 3x. Okay, take a 3x out of 3x squared. What's left behind here? Take a 3x out of 3x squared. What's left behind? X, yeah. Take 3x out of 3x. What's left behind? A 1. Okay. So, let's take a look here then. What do we have? Well, this 9x squared, right? And we have 3x and x plus 1. So let's see here. We have a 9 here. We have a 3 here. So how can we fix this 3 to make it match with a 9? Multiply the top and bottom here by what? 3. Yeah, okay. So I'll multiply the top by 3 and the bottom by 3. Okay, and so now we have 7 over 9x squared minus 3x over 9x times x plus 1, like that. Okay. What else is this denominator missing that this denominator has? We got the 9s to match up. What else is this denominator missing over here that this one has? Okay, this one has x squared. This one just has x. So what do I need to multiply this one by now? An x over an x. Okay? And so I'll get 3x squared over 9x squared times x plus 1. Okay. Do we have like terms yet? Can we put them together now? Not yet. What's this denominator missing? What's it missing? An x plus 1, right? So we'll multiply the other fraction there by an x plus 1 over x plus 1. Okay. Now I'm doing it piece by piece here. If you guys want to take, if you want to do more pieces at the same time, you're welcome to, okay? I'm just doing it piece by piece. So then 7 times x will be 7x. 7 times 1 will be 7. So again, the 7 distributes there to both terms. Okay. And then I'm going to leave this undistributed. So I'll make it 9x squared times x plus 1. Say, multiply them together, right? Minus 3x squared over 9x squared times x plus 1. Okay? Do we have common denominators now? Yes. Okay? So let's see here. That minus 3x squared, remember it's going to be plus negative 3x squared there. There's no like terms up here. So we'll just have negative 3x squared plus the 7x plus the 7 all over 9x squared times x plus 1. Like that. Okay. And I don't think that factors. No. I'm sure it does not. Okay. Yep, that's the best we can do there. Okay. So there it is. Final answer. Questions on any of that? Oops, sorry, I'm off the screen. So then let me give you guys your assignment here I'd like you to work on. All right, it's out of the book, of course. Right? Starting on page 314 in the book, we'll do numbers 5 through 7. That's just simplifying. Okay, so you're not adding, subtracting there, you're just simplifying. Okay, so cancel stuff out. And then 15 to 17, here's the adding and subtracting. Okay, and then I think that's all I have for you. Yep. So, sorry, 9-1, I think. Okay. So section 9.1, page 314, 5.7, 15 to 17. Okay.